All right, welcome back to Thrust Point. Today, we're doing a real deep dive into the critical engineering failure that left 2 astronauts waiting on the ISS and sent Boeing Starliner home completely empty. So let's get right into the schematics.
So picture this, September 2024. The Starliner capsule executes this picture-perfect landing out in the New Mexico desert. The parachutes deploy, the airbags inflate. I mean, it was a textbook return. But there was this one massive, glaring problem that just overshadowed the whole thing. The seats were totally empty.
Astronauts Suni Williams and Butch Wilmore were still up on the International Space Station, basically watching their ride home just leave without them. And that brings us to the core question of our whole analysis today. Why on earth would you fly a brand new spaceship home empty? Well, the answer reveals a failure so critical, NASA just couldn't risk putting the crew on board. To really get a handle on NASA's decision here, you first have to appreciate the huge paradox of how this mission ended.
So let's just let this sink in. You have a flawless landing of a vehicle that NASA mission managers had already decided was fundamentally unsafe for its #1 job, which is, bringing astronauts home. They knew something was deeply, deeply wrong with the propulsion system, and that's the one system you absolutely cannot have fail during that critical deorbit burn.
Okay, so to find the root cause, we've got to pop the hood, so to speak. We have to go inside the hardware. The problem is buried deep within the spacecraft's service module, inside these components that the engineers call the doghouses.
Real quick, a little refresher on Starliner. It's a 2-part vehicle. You've got the crew module, that's the cone-shaped capsule that actually comes back to Earth, and then you have the service module, which holds all the power, the propulsion, the important stuff. And it was right here in the service module where this critical failure happened.
Now, sticking out from the service module are 4 of these pods. They've got this nickname from the engineers, the doghouses. These things house the reaction control thrusters, the little engines used for maneuvering in space. And it's inside these pods that a seemingly clever design choice ended up creating a catastrophic flaw.
And this is where it gets really interesting from an engineering standpoint. The original design logic, it seemed totally sound. Space is incredibly cold, so you need to keep your fuel and thrusters from freezing up. But in solving that one problem, the engineers accidentally created a much, much more dangerous one. They essentially built a thermos.
You see, the problem comes from 2 different heat sources working together. First, you've got solar radiation just baking the outside of the spacecraft. And second, every single time a thruster fires, it generates its own heat internally. Now, the doghouses were wrapped in all this heavy insulation to protect them from the cold. But that insulation was just too good. It also trapped all of that heat inside.
And the consequence was pretty simple. The design accidentally created an oven. Instead of keeping a nice, stable operating temperature, the thruster pods started to cook the sensitive components inside. Okay, so now we're going to zoom all the way in, down to the microscopic level. We're talking about the single component that failed under all this extreme heat and basically grounded the entire spacecraft. We're talking about a tiny, tiny seal.
Inside each and every thruster is this precision part called a poppet valve. Its only job is to open and close with incredible speed and reliability. It controls the flow of Oxidizer. That's the chemical that mixes with the fuel to make it go boom. Bottom line, if the Oxidizer doesn't flow, the thruster doesn't fire. Simple as that.
And right at the heart of this valve is a Teflon seal. Now, on the surface, Teflon sounds like a great choice, right? It's really resistant to corrosive chemicals like Oxidizer, and it's super slippery. But, and this is the absolute key, it has a critical vulnerability, a really high coefficient of thermal expansion. In plain English, when it gets hot, it expands. A lot.
So as those doghouses turned into little ovens, the Teflon seals inside those poppet valves did exactly what physics demanded. They swelled up. The best way to picture it is to imagine a sponge soaking up water and expanding until it completely blocks a pipe. The seals literally swelled up and choked the valve, starving the thrusters of the Oxidizer they needed to fire. The engines didn't just fail, they sputtered and died.
Now this is where the investigation just hits a massive, frustrating wall. A direct physical inspection of the parts that failed, it's impossible, because all the evidence was intentionally destroyed as part of the mission.
See, as part of a normal mission, the service module is jettisoned right before the crew module re-enters the atmosphere. It's designed to completely burn up so it doesn't create space junk. But what that means is the very components that failed, the scorched valves, the deformed Teflon seals, they were all vaporized into plasma. The direct physical evidence, the smoking gun, it's just gone forever.
So this brings us right to the impossible choice that was facing NASA. The telemetry data showed these thrusters were failing intermittently. The engineering models confirmed this heat soak problem. So the question becomes, and put yourself in their shoes for a second, knowing your primary steering thrusters are unreliable, would you risk the deorbit burn?
The answer for NASA was a resounding absolute no. A failed deorbit burn isn't just some minor glitch. If the thrusters failed to slow that capsule down at just the right moment, it could literally skip off the top of the atmosphere like a stone on a lake, sending the crew into a deteriorating orbit where there would be absolutely no chance of rescue. They would be lost in space forever. The risk was just completely unacceptable.
So, in the end, the crew stayed on the ISS to wait for another ride, and Starliner was sent home empty, carrying with it a very, very expensive lesson in thermodynamics. And when we say expensive, we mean it. The final tally for the Starliner program is over $4 billion. This entire multi-year engineering saga basically boils down to a fundamental oversight about how one tiny little component would behave when things got just a little too warm.
And that just leaves us with this final, kind of wild, paradoxical thought. In an effort to keep the system warm and operational, the engineers inadvertently created the exact conditions that caused it to seize up. It just goes to show you that sometimes, in rocket science, trying to keep something warm is precisely what makes it freeze.